Okay, so let's have a look here, right? So we've got to solve tan x equals root 3. You notice the interval which you have to solve it over. You notice the domain you have to solve over. Negative pi to 2 pi. Now at the moment, what angle of measurement are we using? Or what angle unit are we using for this? Radians. Now you remember I always said to you, don't use radians, convert it to degrees because it's a little bit more familiar with you. Then convert it back to radians at the end, right? So what would negative pi be in degrees?
180.
Good, negative 180 degrees, okay? And what would 2 pi be in degrees? 360. Good, 360 degrees, all right? So I always advise convert it into degrees first, solve the question using degrees, and then you can convert it back into radians right at the very end. Make sense? Good. Okay, so here's, so we've got this equation here, so tan of x equals root 3. How are we going to go about solving this? Good, so the first thing we need to do is find the base angle, and we do that by taking the tan inverse of root 3, and that will give us x. So has somebody done that? Or somebody might know it? Remember it's one of those angles you say? What was it? 60 degrees, perfect. Okay, so this is what we call the base angle. This is the angle which is closest to 0 degrees. But you remember, you're expecting more because you want to solve over this entire domain. Okay, so to find the other angles, what are we going to do?
Draw the graph.
Yeah, draw the graph. Now, what does the tan graph look like?
What's it called? The line that doesn't touch
It's called an asymptote.
sorry.
Yeah, good. So it's the one with the asymptote. So somebody's draw it in the air, what does it look like?
Like this.
Yes.
Like this.
Yeah, absolutely. So it needs to be one of these graphs that you need to know how to draw. So it kind of comes down and comes up like this, okay? Then you've got asymptotes bounding either side of this, okay? What's that point there? Anybody remember? This point there. Good. Negative 90 degrees. What's this point here? 90 degrees. Perfect. Remember, every 90 degrees something interesting happens on the tangent and the sine and the cos graphs. That's interesting. Goes to the axis. That's interesting. That's interesting as well. Make sense? Good. Okay. Now I need it from negative 180 to 360 degrees. So I need to go another 90 degrees back. Are you happy? Well, another 90 degrees back will be going through the axis. You happy? So in other words, I'm expecting this to happen. But if I only go 90 degrees back to negative 180 degrees, that's as far as I want. In other words, I don't want all of this negative portion of the graph as well. Does that make sense? Yeah? Okay, good. Then I just need to keep going until I get to 360 degrees. So I'm going to draw another one of these things. So I'm going to draw another one of these things, okay? Well, another 90 degrees on is going to be where? Yeah, 180, okay? And then another 90 degrees on has to be an asymptote, so what's that point going to be? Careful, another 90 degrees further on. That's interesting, yeah. And I need to continue because I need to go all the way to 360, so I'm going to draw another one of these things, okay? Well, if I think another 90 degrees on to this point here, where it goes to the axis, what's that going to be?
360.
Good, that's going to be my 360. So actually I can stop there, so I don't need all of this as well. Does that make sense, the thought process which I've gone through to draw that? Good, fantastic. So now I need to come back to this thing. I'm basically asking what angles in this graph, so what x values do I stick in, and I get height of root 3 out. Well, root 3, doesn't actually matter where you draw it, is going to be probably about there. Okay, it doesn't actually matter where you draw it, as long as it's on the positive portion of the graph. Then what do?
We make a line.
Good, we draw a line all the way across, right? And make sure you draw it all the way across your graph. Okay? Right, so we've got one point already. What's that point there?
Where? Oh, yes.
That's the 60 degrees. We've already found that over here. All right, that's the base angle. That's the angle which is closest to 0. Okay? But then we've got another point over here, and we've got another point over here. So how could we find those two other points? So that point there you're saying is 240. Why? Okay, so you're thinking you know that the graph is periodic, so every 180 degrees you get another copy. Absolutely. If you didn't quite think of it that way, another way to think of it is you can say, well, hang on a minute. The distance from where it goes through the axis to the point which you're after is 60 degrees to the right of it. Make sense? So the distance from where it goes through the axis to the point which you're after is 60 degrees to the right. Do you see that? That's 60 degrees, okay? We'll have a look. That's the next point that it goes through the axis, which means that the point which I'm after must be another 60 degrees to the right of 180. Do you see that? So you go 180 plus 60, which is your 240. Perfect. Okay. And the same kind of idea here. That's where it goes through the axis. If you go 60 degrees to the right of negative 180, where'd you get to? Good, negative 120 degrees. So actually my three angles which I'm after are going to be x equals negative 120 degrees, 60 degrees, or 240 degrees. Okay? Am I finished? Why not? Good. The original thing was given in terms of radians, right? So you need to make sure that you leave your final answer in terms of radians as well. Just remind me, how do I convert a number from degrees into radians? Perfect, yeah. So I need to times all of these things by pi over 180. So, okay, so times this by pi over 180, that's going to be negative 2/3 of pi. Times this thing by pi over 180, it's going to be pi by 3, isn't it? Okay. And times this thing by pi over 180, that's going to be 4/3 of pi. Just check those in a calculator, I think that's right. Okay. So this would be my final answer. Now in the exam, these things will be quite generous. Okay, I'll be quite generous with the marks for these things. I can understand, well, let's think. A question like this would probably be maybe 4 or 5 marks. Okay, let's see where the marks will be awarded. Okay, so 4 or 5 marks. Number 1, finding that base angle. Okay, finding that base angle. Okay. Number 2, an accurate drawing for the graph. There'd probably be 2 marks for this. Number 1, getting the shape of the graph right, and the second mark for getting it within the required domain. Okay. So if you do it from negative 180 to 360 degrees accurately, you'll get 2 marks. So already, that's not difficult, right? That's 3 marks. Yeah? The 4th mark will probably come from this, finding them all accurately. Yeah?
So we should definitely go for step.
Yeah, absolutely. I mean, you can kind of see it as a recipe. So if we think about it, for solving these types of equations, what's the first thing that we need to do? Sorry? Yeah, find the base angle. Okay, so find the base angle. Now, as you'll see with this one down here, slightly different. You need to do sort of slightly more work for it, and there'll probably be an extra mark for that. Okay, but number 1 is definitely find the base angle. What's the second mark? Or what's the second thing we need to do? Yeah, good. Draw the graph. Okay. What's the third thing we need to do? Yeah, good. Basically, find all of the angles which satisfy that. So you need to draw the line across. Okay, so draw horizontal line. And then we can use that to find the angles, right? Can use that to find the angles. Cool. Okay, and then what's the third thing we need? Sorry, what's the 4th thing we need to do? Yeah, if necessary. So I'll put it as like a 3, I'll put it in 4 in brackets, right? Because you don't always need to do this. It depends what form it was given in to start off with, but just make sure that you convert the angles back. So that step may not always be necessary because I might be generous and give it to you in terms of degrees, okay? But if I give it to you in terms of radians, you definitely need to convert them back into radians again. Is that okay? So it's really just a 3/4 step process. It's not difficult, okay? And there's a good sort of number of marks being awarded there.